Okay, good evening, ladies and gentlemen, and welcome to this live session on Lean Six Sigma. We are going to cover statistics, basic part today, and which is going to be very important session. So before I begin, let's welcome the new members in the team. Whoever attending the session first time, just type me in the chat box. We will all welcome you first. Okay, everybody, all the new members in the room right now, because Monday we have a lot of न्यू मेंबर ज्वाइनिंग इन द सेशन ओके हाँ जी रितेश जी है और ओके और कौन कौन है पारुल जी है हु एल्स यू इफ यू आर अटेंडिंग द सेशन फर्स्ट टाइम जस्ट टाइप मी इन द चैट बॉक्स आपने शायद एडमिशन 2 हफ्ते पहले लिया हो लेकिन यू आर अटेंडिंग फर्स्ट टाइम सो विल वेलकम यू ओके शेखर जी है सुपर सुपर ओके दीपक जी ऑल्सो सो एवरीबॉडी just type welcome all new members in this community, give them the warm welcome, and give them all the wishes. They can complete their destination of Lean Six Sigma Green Belt, Black Belt certification, and keep continuing, in their fast track growth path with this. All right, everybody, just type welcome new members and wish them all the very best. Super, super. Welcome, welcome, welcome. All the new members. I think a lot of people are yet to join in, and we will welcome them eventually as well. Super, super. So today's topic, we are going to discuss about something which is in the phase of, in the DMAC framework, this is the phase where statistics comes. Okay. Yeah, let me just share. Now, this is your green belt topic itself, and the phase is called major phase. See, in the DMAC framework, everybody, for your information, okay, in this framework of DMAC, in the define phase, we all know that, you define the project, the problem very clearly with, your, what you can say. Thank you very much for the appreciation, and Protik ji and Gaurav ji. Thank you very much. Okay, so this DMAC framework is all about, in the define phase, what we do is we cover, what you can say, completely clearly define what is my problem. Okay, so we use project charter, which we have already seen in the, in our yellow belt session as well, right? How to write a project charter, problem statement, goal statement. Then so any challenge we have, any operational level challenge we have, we convert that into project. And then we make a team of cross-functional team members and start driving the project. Okay, so we define the problem, we, make a team, we make a, complete plan of, let's say, 3 months time on an average. Every Lean Six Sigma project runs for 3 months. Average I'm talking about. Then you start working on that. After that, the second phase comes. It is called a major phase, where statistics and data comes into picture. So today we are going to talk about the phase called major phase. So major phase is the phase where we'll start collecting the data about the problem and we'll start dealing with that. Okay. So today we are going to focus on major phase. This slide deck is exactly available in your green belt curriculum. Okay. So I'm talking about that only. So in the major phase, basically, the tagline of major phase is you can't manage what you don't measure. Very, very powerful tagline, guys. You can't manage what you don't measure. Example, the biggest challenge of what you can say, the family people, is their finances, right? खर्चे कहां पे हो रहे हैं हमें पता ही नहीं चलता. How many of you have that kind of situation? Yes, just give me yes in the chat box. Where the expenses are going in a month, we are not able to track. How many of you have that challenge? Just give me yes or no in the chat box. Yes, everybody, just give me yes or no in the chat box. How many of you struggle? Let's be very honest. See, we all are selling the same word, okay? Nobody is financial, what you can say, literate or a genius. There are few people, but they are in minority. Let me be honest with you. Now, second option. How many of you think that, how much, whatever hard work I'm doing, I don't know where the time flies, where the time goes. How many of you feel like that? And whatever important stuff you plan, that doesn't happen. and the time goes away. How many of you feel? Just give me yes in the chat box. Everybody feels the same way. A lot of us. What does it indicate? Because we are not tracking that, we are not measuring that. Understand this? The moment we start tracking that, we get the control. You start tracking your expenses, you'll get the control. You start tracking your hourly, whatever task you have done in that hour. If you start tracking that 8 hours to 10 hours every day, that will give you immense clarity where that is, where your time is going, where your money is going. The same applies to your process. If in your process, if there are some defects, there are some quality problems, customer complaints, and you're not able to manage it, that means there is something wrong with the measurement. So we are not measuring it properly. The measurement has to improve. So in the measure phase, what we do is so everybody knows input, process, output, measure, right? So in the measure phase, we start collecting the data of inputs as well, of process as well, and output as well. We start collecting all the data points, and then we start tracking the data by using the statistical tools. So this example is very simple. The tea making process, chai banane ka process, very simple process. Okay. So in the input measure, what do we, how much of Six Sigma is statistics as percentage? I would say around 30-40% statistics is used. But you know what? I'm of the opinion. Now I have seen both the spectrums. Just to answer this question, okay? I have seen very what you can say, very recognized and very traditional universities. Let me take some names, okay? See, this is on air now. It is going on YouTube as well, live. Let's say Indian Statistical Institute. I really respect. Even IIT Kharagpur. I'm a student of that. Now, in these very recognized and reputed institutes, they go very deep in statistics. They go very deep in manual statistics as well. You have to calculate it manually. Okay, so understand this. What happens is now it is up to you. If it is of your passion, if it is of your appealing, if it is your calling, that you love statistics from the core of your heart, then you can go that way as well. But we have statistics packages, we have Minitab softwares, right? We have Excel, we have Minitab, we have calculators. So how much time do we want to go deep into that? That is something which we have to see. Ultimately, we use Lean Six Sigma to solve the problem. Business requires to solve the problem quickly and effectively, rather than, see, we at the end of the tunnel, at the end of this process, we want champion problem solvers and not champion statisticians. Understand the difference between these two. Statistics is a big science, it's a big ocean. हमें 7 जन्म भी कम पड़ जाएंगे सीखने के लिए. But whatever is required, whatever is essential to solve the problem, that is what. So to answer the question, I think 30% would be a right answer. Okay, in all DMAC framework, 30% statistics is used. And I am of the opinion that you understand it at least once, okay, but you use it only to solve the problem and not to become a statistician. That will be my recommendation. Okay, coming back to types of measure. Input measure. Okay, yeah, sure. So we will have the question and answer at the end of the session. So the forum will be open. You can ask any question related to this. Okay. Now, coming back to this input, process, and output measure. What we do is, now, if I want to improve the quality of my tea, the test, the delivery time, etc. Okay. So I have to start measuring all the parameters: input parameter, process parameter, output parameter. This is applicable everywhere. I'm running hospital, I want to increase the patient's satisfaction score. I have to basically check the input parameter. What is the time they are waiting in the OPD? What is the how much time they have to spend for the consultation? All right, what quality impact, within how many days the patient is getting cured? So all these are the parameters I have to measure just to check the satisfaction score. Then hospitality of my staff, the cleanliness, the hygiene, etc., availability of the doctors. All these things will happen in the hospital. All these things will happen in the hotel. in your process as well. So input measure is whatever you can measure, qualitative and quantitative. We will start collecting the data. At this point in time in the measure phase, we don't know which measurement is critical for us and which is not. But nonetheless, we have to collect all of them. Okay, so we list all the input measures, all the process measures, and all the output measures. Can anybody tell me in the define phase which tool will help you to find out what are those input, process, and output measures? Type in the chat box. In the define phase, there is a specific tool we use which can give us all the details of this input, process, and output measures. Type in the chat box, everybody. Let me see how many people can answer this question. See, right now we are in measure phase, but in define phase, there is one tool we use for this. Very good. Very nice. Satishji, your answer is absolutely right. Yes, Parulji, absolutely right. It is SIPOC, SIPOC. SIPOC, supplier input, process, output, and customer. This is a tool we use in define phase, which lists down all the inputs, all the processes, all the outputs. And here in the measure phase, we just have to collect the data related to that. That's it. Are you clear, everybody? Now let's do one thing. Everybody in your process, in your own process, okay, write down one input measure, one process measure, and one output measure. For example, let me give you this example. For tea making process, quantity of sugar, quantity and quality of milk, quantity and quality of water. These are the input measure. Process measure में क्या है? Temperature of of that mixture, basically in the process. How much time you are boiling to brew that entire mixture, and its stirring time. How much time are you stirring the entire mixture? Then the output measure could be the test of the tea on the scale of 1 to 10, turnaround time, or maybe temperature of the cup of tea also can be output measure. At what temperature you are serving the tea, that also can be output measure. So in your process, give me, okay, just put like this. Put I, which is input measure, and give me that measure. Give P and give me that measure, and then give O. Okay, input, process, output. All right, and just type in the chat box, everybody. If you are not working, you can take example of your previous company, or you can take any generic example. All right, if you're a student, if you're not working, then take example of your previous company, any company, or any process, or any generic example. Just type in the chat box so that we understand that you have understood this concept of types of measure, input, process, and output. Everybody, quickly just do that. I want to cover a lot of things today in this topics. Okay, so we'll just move a little faster today. Give me that quickly, and so that I can move forward. Input measure is percentage FFA. Process measure is alkali concentration, mixing time, temperature, mixing speed, and output measure is percentage FFA. Okay, good. FFA is free fatty acid of crude oil. Very nice. Thank you very much for clarification, Akshay ji. Amazing. Super. So Akshay ji ने जैसे दिखा है. Okay, just give me at least one or two in the process measure. That's it. एक भी चलेगा मुझे. So that your concept is clear. Okay, one input, one process, and one output measure will be good enough. Clear? And if you're writing one, just type, give me the critical most one. Now, entrance test. Okay, so what you will measure? What will you measure? Entrance test score. Entrance test score is a measurable aspect. So here it should be a measurable aspect. Understand this? Okay. So process measure could be internal, so process measure could be the study time, and then the external final exam score will be the output measure. Yes, very good. Then API excipients, the quantity. Yes, Anuj ji. So API ka quantity kitna hoga, excipients ka quantity kitna hoga, that will be the measure. String speed, starting speed, pH level, clarity, all these things will be, and assay percentage will be the output. Fantastic. Attending Zoom meeting is the input. Okay. Keep ready requirement. Output is how the session and what I learned. Okay, well, that's very good. Fantastic. Super. So are you clear what you want to measure? It should be a measurable aspect. Okay. वो measurement होना चाहिए. Clear everybody? Just give me yes in the chat box if it is clear with you. So in the measure phase, what we do, we cover all the input, process, and output measure, and we start collecting the data about it. That data might be important, might be critical, we don't know. But we start collecting the data right now from the measure phase. Clear? And that we will use it in the with the help of Minitab. Okay. Now, so once we collect the data, there are two types of data we'll come across. One is called continuous data. Second is discrete data. Continuous data is like length. See, continuous data is measured. Understand this. Make a note of this. Continuous data is measured. And the second type of data is called discrete, which is counted. Example, the length is always measured. The height is always measured. The weight is always measured. Understand this? And on the other side, we always count the number of males and females in the room. We always count the number of accepted pieces and the rejected pieces. We always count the number of passed students and the failed students. Are you understanding? So we measure, whatever we measure, it's called continuous data. Whatever we count, it's called discrete data. Okay. Whatever, we can basically measure on a continuous scale, like 1.1, 1.2, 1.3, 1.5, 1.92, 2.1, 2.22. So on a continuous scale, we can measure, that is called a continuous data, and 1, 2, 3, 4, nothing in between. That is called discrete data. Are you clear? So continuous data can be expressed in the decimals. Discrete data generally is, 1, 2, 3, a whole number. Are you clear with this? Just type yes in the chat box, the data type. Clear hai everybody? Continuous, discrete. If it is clear, just give me one example of continuous and one example of discrete in your process. Just type C, continuous. Just give me one example. Just type D, discrete. Just give me one example. Type in the chat box. So basic fundamentals of statistics we are just discussing here. Continuous data and discrete data. Microns and inches. Okay, what is a discrete? Quality is continuous data, number of errors is discrete. Quality in what? What is the measure of quality? Just give me one example. Be a little specific. Height of the student, very good. Marks obtained, yes. 100 marks, 50 marks, 70 marks, yes. Room temperature, humidity is continuous data, very good. Number of people in the room is discrete data, very good. Vernier micrometer. No, if I'm measuring anything on vernier and micrometer, that will be a continuous data, not discrete data. Now, how many verniers I have, it's a discrete data, understand this. But whatever I'm measuring with the vernier caliper, yes, it can be a continuous data. Clear? Weight of the apple is continuous data. Very good. And number of apples is a discrete data. That's a fantastic example. If I weigh the apple, that's a continuous data. And number of apples is a discrete data. Fantastic. Very good. Very nice. Super, Pratik ji. Call it quantity of raw material of production is quantity of raw material. Let's say if it is in decimals, it's in continuous data. Number of manpower on the planet is discrete data. Very good. Number of instruments is discrete. Fantastic. Superb. I think you have all got this continuous and discrete wala thing. Okay. So always continuous data always gives us more information. Remember this. Continuous data always gives us more information. Example. Let me give you example. Okay. Let's say there is a weight of chocolate. Okay. And I am the, what do you say? I'm the quality inspector. Okay. And my rule is anything less than 10 gram is a defect. I will not accept it. Okay. So I check the first sample, which is 10.1 grams, which is okay. So I accept it. Then second sample comes 10.2. I accept it. Third sample comes 9.9. I reject it. Okay. Again 10. I accept. Again 10.2. I accept, etc. So finally, I will get, okay, I will get, let's say 15 accepts and 5 reject, let's say, out of 20. Imagine this. So this is called a discrete data. This is called discrete. And this 10.1, 10.2, 9.9, 10.0, this is called a continuous data. So this is continuous and this is discrete. Now, with discrete data, okay, only thing is that I know that these 5 chocolates are rejected, 15 are accepted. Now, but with the continuous data, I can make a trend out of it. I can make a control chart out of it. I can make a histogram out of it. Are you understanding this? With the help of continuous data, I can do a lot of things. I can do standard deviation. I can calculate standard deviation sigma out of it, which we are going to learn. So with continuous data, we always can do lot of statistical analysis. So if a choice given, try to collect continuous data as much as possible. Are you clear with this? Just type yes in the chat box. Are you clear? So continuous data will always give us more edge, I would say, more leverage in terms of statistical tool application. Okay? Yes? Yeah, air pressure is continuous and the number of products output is discrete. Very good, very good. Super. Clear hai? Continuous discrete is clear? Now, so let's enter into statistics. What is statistics? Statistics is a science in this is my understanding of statistics. Okay. Statistics is science which, just a second. Statistics is a science which converts data into information. The simplest definition of statistics I have made. So we collect the data as the input, we put it in the statistics and we get information. Example, I collect the data of the chocolate weight. Chocolate weight. So I've collected the data. That data will not make sense any sense to me. So I convert that. I convert that into, let's say, a time series plot. What is time series plot? Just like a trend chart, let's say, for example, like this. Okay. So I will get the information, okay, about the trend. I will get the information about the trend. Now, the moment I investigate about the peaks and the valleys of the trend, I will get the wisdom about my process. And this is the entire chain of the statistics. I collect the data, I convert that data into some kind of a graph or a statistical model. That model will give me some information. And if I go deeper to investigate that, I will learn something very important about my process. I will come to know that if I increase the temperature, then my my chocolate weight goes down. If I increase the humidity, chocolate weight will stable, like that. Are you understanding this? Have you understood? Data into statistics, into information to wisdom. So this is what is the, yes, exactly. We can say that. It's a processing of the data. It's a processing of the data. So extracting information from the data is statistics, which can be used to make important decisions for your process, for your business. This is all about statistics. Clear? Statistics is all about collecting, analyzing, representing, interpreting the numerical data. Yes, very simple explanation. Now, let's go to this. When I say statistics, there are two parts of statistics. One is called descriptive statistics. Other is called inferential statistics. Let me give you an example of this. Now, let's say right now there are 30 to 40 people sitting in the room. And we have, imagine the total, let's say, total students, okay, of SNG, let's say, are 5,000. Okay. I don't know the exact number, but let's take 5,000. So 5,000 becomes the population. And let's say 50 people sitting here are called sample. Are you clear? Sample is a representative of the population. Are you clear? You know sample and the population theory. Just type yes in the chat box. Very simple. We have learned it in the schools and colleges. Yes, very simple. Sample is a whole. Let's say the population of India is 1.4 billion, right? And let's say if I collect 1 lakh people data, right? Like during the election, etc. These people do the sampling, okay? And on the basis of sampling, they basically give some kinds of what you can say results ka probability, right? So it's called population. So they cannot go to each and every person ask their opinion, right? It's not possible. So they collect the sample of the data, exit polls, yes, exactly, which go horribly wrong every time. But anyway, they take the samples, and then they reach out to representatives of the population, and that is called sample. So sample represents the population. So what we do is, if we are collecting the sample and analyzing the sample, that is called descriptive statistics. So this is all about sample. Okay. Let me give you a simple example of a cricket match. In the cricket match, let's say T20 cricket match is going on. Okay. Now, let's say IPL match is going on. 5 overs. The score is 5 overs. And we have 40 runs and 2 wickets. It is a score. Now, this is a sample of 20 overs. Okay. And this is called descriptive statistics. We are giving description of that sample of 5 overs. So this has already happened. So we can say it's a past data. Understand? So descriptive is all about the sample, a subgroup of the entire population. And on that basis, we infer. Now, in the same match, there is something called projected score. How many of you know projected score? If this continues, maybe you can reach up to 160 runs or 170 runs or 180 runs, right? That is called projected score. Yes. And that is called inferential statistics. So inferential is about the population. It is about the future. Okay. Example, projected score. Are you clear with descriptive and inferential statistics? Just give me yes in the chat box. Are you clear with this? Simple, samajh mein aaya, right? Another example. So I've given you election exit poll example. I've given you cricket example. Let me give you, when you go to a pathology lab, let's say you have some fever, correct? Right? So you go to doctor first investigates, and then doctor asks you to go and check your blood, right? So you go to pathology lab, and that lab technician basically takes out a small sample of blood. Generally, we have 5 to 6 liters of blood. That's what we say, right? So they take a small sample of the blood, and they check what kind of viral infection you have, right? And they give you the report. Then you take that report and go to the doctor once again. So that report is descriptive statistics. In that report, any viral infection is there, your WBC, RBC count, cholesterol level. So all those things will come in that report. That is the descriptive statistics. And then from that report, doctor will, so in that small sample, if this is a viral infection, that might be there in the population, which is the entire blood, right? So accordingly, the doctor gives you the medication. That's the inferential statistics. Are you clear with this? Just give me yes. Super clear hai ye? Sample population theory clear? Yes. Now, in the descriptive statistics, okay, yahan tak clear, everybody with me? Very good. Now, in the descriptive statistics, we have all seen the bell-shaped curve. Everybody has seen this? Which is basically comes out of histogram, correct? Which looks like this. Everybody knows this, correct? And this is also called as normal distribution. You might be heard about this. Normal distribution. Why it is called normal distribution? Because you collect any data, you will see this pattern emerging. It is so normal, it is so common. That's what it's called normal distribution. You collect any data. Let's say right now there are whatever 30, 40, 50 people. If we collect the weights of the people, all the 50 people, put it in the software, the same pattern will emerge. If we collect the height of, height in the centimeters, the same pattern will emerge. Understand this? It is so normal, it is so common, it is absolutely available everywhere. That's why it's called normal distribution. Okay, so in the normal distribution, there are two very important characteristics. One is called the center of the normal distribution. Where is the center? Which is a very important part. Okay, and that is called as central tendency. Center is measured by the central tendency, which is, there are three measures: mean, mode, and median. And the second parameter is what is the spread of the data. How much is the data spreaded across? And that is called the dispersion. And for the dispersion, we have range, variance, and standard deviation. These are the three measures. Are you clear? Just give me yes in the chat box. Yeah, clear hai? So in the normal distribution, a center is an important parameter and a spread is an important parameter. So in the center, we have mean, mode, median. And for the spread, we have range, variance, standard deviation. Clear? So ये दोनों आपको याद रखना. Just take a screenshot of this if you wish. Just take a screenshot. If you're clear with this, just give me yes. Clear hai? So this is what we are going to cover today. Mean, mode, median, range, variance, standard deviation. On the other side, in inferential statistics, we predict about the behavior of the population through hypothesis testing, regression, process capability analysis, like CP/CPK, process capability, or we can say design of experiments, DOE. All these parts, some part we cover in the green belt level, and the advanced part of all these things we cover in the black belt level. That is called inferential statistics. So today we are not going to touch upon that part, but we are going to touch upon the descriptive statistics part. Clear, everybody? Just take a screenshot and just type yes in the chat box if you're clear with this. Now we are going deeper into central tendency and then dispersion. Clear? Everybody clear? Just give me yes. किसी को कुछ भी समझ में नहीं आया, please type in the chat box. Can you repeat this point? Okay, I've just given you overview. Now I'm going slowly. First, we entered into what is measure, types of measure. Okay, types of data. Now, when we start collecting data, then we come to statistics. What do we do with the data? We put that data into statistics to get the information. Okay, when we put in a statistics, there are two parts: descriptive, inferential. In the descriptive, there are central tendency, dispersion. In the central tendency, mean, mode, median, dispersion, range, variance, standard deviation. Now let's go deep into mean, mode, and median. Starting with the mean. Okay. So mean is simple average of the data. Very simple. It's arithmetic average. Nothing rocket science. You add all the numbers divided by number of data points. That will give you the arithmetic average. It's called mean. The average, simple average. Okay, if all the 50 people height is taken, then you take the average. Let's see, the average height comes to 155 centimeter. That's the simple mean. Okay, clear? So the sample mean is basically shown as X bar, and population mean is shown as mu. This is the mu. So sample is considered as X bar and population mean is considered as mu. Okay, just for your information. Then comes mode. Okay, so mean ka example yahan pe diya hai. If there are 5 days production, 500, 750, 600, so you add them up, divide by 5, so total is 615. So we can say that the average production every day is 615. Okay, so how many computers they are producing? So 615 computers they are producing every day. Simple, average. Okay. The second is called mode. Mode is the most frequently occurring data in the data set. Whichever data is coming back maximum time, repeating maximum time, that is called the mode. Most frequently occurring data point. So in this data set, what is the most frequently occurring data point? Type in the chat box. Observe this data set. Observe it very clearly, and which data point is coming maximum time. Type in the chat box, everybody. Very good. It is 75, correct? So if I have to plot this distribution, it will be like this. Okay. So here it is frequency and here is the actual data point. So I'll start with 60, 65. Let's say this 60, 65, 70, 75, 80, 85 kind of thing. Okay. And 90 also is there. So 60 में कितना है? Let's say 1. Okay, 1, 2, 3. So frequency. So here is 1. Okay. Then we have 65 में कितना है? 65, 67 would come together. So it will be like this. 70 also, there is nothing in 70. 75, we have 3 data points. So I'll have 3 data points like this. 80, I have 1. And 85, I think 90, I have 1. So this is a distribution of the data. Are you clear? Clear है everybody? Just give me yes in the chat box. 82 बार है क्या? अच्छा अच्छा, okay, thank you very much. So it will be 2 times. So it will come something like this. Clear है everybody? Just give me yes in the chat box. This is just a simple histogram I have created manually. समझ में आ गया आपको ये कैसे डिस्ट्रीब्यूशन होता है? And the highest one is the mode. So in the distribution, the highest peak is called a mode. Is it clear? Just give me yes. 1, 2, and 3. Everybody clear with this fundamental? I've just plotted these data points on a histogram like this. Okay. Now, what if I have another 80 here? What will be the mode here? Now we have 75 3 times and 80 also 3 times. 1, 2, and 3. What will be the mode in that case? What will be the mode? Average of 70 and 75 and 80. Yes, type in the chat box. You can give wrong answers. Absolutely right. Absolutely okay, because we are here to learn. Yes, 75 and 80. Fantastic. So the right answer is there are 2 modes here. One is 75 and second is 80, and this is called bimodal distribution. See, normal, now it is not average of both, huh? This is not average of both. I'll clarify this. Now, see, in the normal distribution is also called as unimodal distribution. Uni meaning one, only one, uni. Okay. Bimodal meaning it looks like a camel back. So in this will be 75 and this will be 80. If I plot this, it will look like this. Yes, everybody? I just plotted histogram. So this histogram would look like this. Can you connect now? This will look like a camel back. Just a double hump wala camel back or a double speed breaker wala thing. It's called bimodal distribution. Bimodal distribution is not a normal distribution. Bimodal is not normal distribution, even though it is symmetrical. You will say, see, if I split it into half, it will have 2 symmetrical, distribution. But no, normal distribution is always and always a unimodal distribution. Only one mode. Clear, everybody? Another question. No, so average I will clear. This is not average. Modal mein average nahi hota. That comes in the median part. Okay, that comes in the median part. The average comes in the median part. I'll explain it to the next part. Now, what if all the data points all of them are having the same frequency? What will be the mode of that? Second question. All the data points will have the same frequency. What will be the mode of that? Type in the chat box. What will be the mode of that? Have you understood my question? Let's say 75, 2 times, 60, 2 times, 65, 2 times, 75, 2 times, like that. All of them are with the same frequency. What will be the mode? Type kariye. Give the answer. Multimodal. That's a fantastic answer. Multimodal. Yes? No, very good. So actual answer to that is it is called a no mode distribution, or it is called as uniform distribution. Make a note of this. Uniform distribution, and it looks like this. All of them will have the same amount of frequency. It will be a rectangle kind of a shape will come. It is called uniform. This is also not the normal distribution. Clear everybody? Mode clear hai? What is mode? What is unimodal? What is bimodal? What is uniform distribution? Just give me yes in the chat box. Clear? Super clear with funda? Yeah, these are all fundamental things. एक बार understand करना है, you will easily understand later. Okay? Yes? Very good. Generally, we don't come across this much, but if it come across, you should be aware of this. Okay? Generally, we will come to know about the normal distribution only, most of the times, right? Now comes to the median. What is median? If I take the same data, arrange the data into ascending or descending order, whatever comes in the center, it's called the median of the data. Okay. If I arrange this, let's say this is the data set. If I arrange the data set in the ascending order, okay, there are 7 data points. So the fourth data point will be exactly in the center. It's called median. Clear? Now, if I have 8 data points, let's say I have added 42 here, then I will have 2 data points at the center, which is 19 and 25. So I will take the average of 19 and 25, and that will be the median, which is 44 plus 2, it will be 22. So 22 will become the median. Are you clear? In the mode case, it is not the case. Okay. If there are 2 modes, then you have to say that there are bimodal distribution. Are you clear? Okay. Here in this case, you have to take the average of the 2 central values. If the data points are even in number, you will get 2 central values in the center. So you have got to take the average of this. This is called median. Clear? Mean, mode, median. Variance, standard deviation. Variance, standard deviation अभी तक मैं किया नहीं है. But mean, mode, median is clear. Just give me yes in the chat box. Super clear है ये? Very good, very good, very good. Now, in the same point, let me explain you the concept of percentile. Generally, we hear the concept of percentile. 4 is the central. Why to take the average? With 4 data points, no. If I take the 8 data points, the 4th value is not in the center, no? Can you see here? With 8 data points, you can see here 1, 2, 3, 4, 5, 6, 7, 8. There are 8 data points, right? So in the center, I have got 2 data points exactly in the center. If I want to split that values into half, I'll have 2 data points in the center. Clear? And I have to take the average of these 2. Clear hai ye? Just give me yes in the chat box. If you have 8 data points, I don't have only 1 data point in the center. I'll have 2 data points in the center. Just give me yes if you have understood this. Clear? Just give me yes. Okay, very good. Now, let's talk about quartile and percentile. What is percentile? Let me just give you a very simple example. We have heard about percentile in our examination result, etc. Right? Correct? The joint entrance examination nikla. बच्चे को कितना percentile मिला? Percentile, not percentage. Percentage is simple. That calculation is simple, right? Per 100, how many marks he has scored, that he or she. That is called percentage. But percentile is a little different concept. Let's take an example. Imagine this, this is a cake. If I arrange the data set in the ascending or descending order, imagine it's a piece of big cake, a horizontal cake. Okay, a rectangular cake, placed in the, let me draw it over here. Okay, this is a cake. And there are 100 people in the room. I want to cut the cake exactly into 100 pieces. So how many cuts I have to make? Type in the chat box. How many cuts I have to make exact 100 pieces? Type in the chat box, everybody. 99 cuts. So every cut becomes the percentile of that data set. Every one cut is the percentile of the data set. Okay, just understand the concept first. Okay, slowly that will connect the dots. Clear? So imagine a data set as a cake, horizontal cake, and I have to cut that entire data set into equal 100 parts. So I will make 99 cuts and every cut is my percentile. Now the same applies to quartile. Okay, let me just remove this. The same applies to quartile. Quartile meaning quarter. Let's say there are 4 pieces I have to make of the same cake. So how many cuts I have to make? How many cuts I have to take? Type in the chat box, everybody. How many cuts? 3 cuts. Are you clear? Which will make 1, 2, 3 and 4 parts. Are you clear? So every cut becomes my quartile. There are 3 quartiles. So this is my quartile 1. This is my quartile 2. This is my quartile 3. There are 3 quartiles. Are you clear with this? Just give me yes quickly in the chat box. So I arrange the data in the ascending or descending order, and I cut exactly into 3 types, 3 parts. So that will make 4 equal parts of that. And every cut is called my quartile. Now, can I say quartile 1 is equal to 25th percentile? Can we say that? Percentile is for the 100. Quartile is for the 4. Can we say first quartile equals 25th percentile? Yes or no? Everybody just think about it. Can I say quartile 2 is my 50th percentile? Can I say quartile 3 is my 75th percentile? Yes. Everybody? Can I say quartile 2 or 50th percentile as my median? Can I say that? With the same example, if I arrange the data set, whatever is the central value, that is called my median. Quartile 2 is median, is nothing but 50th percentile. Are you clear? Percentile, quartile. So in this data set, now look at this, guys. This is my quartile 1, this is my quartile 2, and this is my quartile 3. Quartile 2 is nothing but my median, which is my 19. How many of you are just type C in the chat box if it is clear to you? Just give me C. Super. Amazing. Amazing. Okay. Very good. Now, let me take you. So this is mean, mode, median, percentile, quartile. Clear hai? Just give me yes in the chat box. Mean, mode, median, percentile, quartile. Clear? Now, let's go to the dispersion of it. Okay, you remember? First is the central tendency. This is a central tendency, which is mean, mode, median. Now we are talking about a dispersion, how much the data is spreaded. And for that, we have got 3 parameters: range, variance, and standard deviation. Okay. So let's come to the first parameter, which is called range, which is the simplest one, which is nothing but the highest value of the data set minus the lowest value of the data set. Okay. So they have taken 7 production days. Okay, so the highest production is 900 and the lowest production is 300. So the range of the data set is 600. And that is called one of the criteria to find the variability, which is the dispersion of the data. So range is a very basic parameter of the dispersion. Okay, now after the range comes the variance and standard deviation. And for that, I have created this, this simple explanation. Let's go through this example so that you will understand it very easily. Okay, we'll calculate it manually so that it will be very, very easily understood to you. Okay, now let's collect it. So there are 6-step process to identify variance and standard deviation. Okay, sigma. Basically, we are understanding how to calculate sigma. Okay, in a simplistic manner. Basically, this is how the sigma formula is arrived. Okay, so I'm just going deeper into that. So first step is to collect the data. So we have collected the data, which is 10, 12, 15, 18, and 20. First, you collect the data, and second, you take the average. If you you take the average of this, you add them up and total it up, it comes to 15. So 15 is your average mean. Okay, so first step is collect the data. Second step is collect the average or check the average. Third is from that average, you calculate what is the deviation. Okay, because the dispersion is what about nothing but the distance, right? So the average becomes the reference value. From the reference value, what is the deviation? What is the distance of each and every data point we have to calculate? So here, the step number 3 is calculate the deviation from the mean value, which is D1, D2, D3, D4, and D5, which is deviation 1, deviation 2. So deviation 1 will be 10 minus 15. So 15, let's say, is the average value. This is my X bar. So what is the distance from 10 to 15? The distance is nothing but minus 5. How many of you understood this? Just give me yes in the chat box. The distance is minus 5. Have you understood this? 10 minus 15 is equal to minus 5. All right. What is the distance between 12 and 15? It is minus 3. What is the distance of 15 and 15? It is 0. What is the distance of 18 and 15? It is plus 3. And what is the distance of 20 and 15? It is plus 5. So, or you can say just 5. Clear? So, minus 5, minus 3, 0, 3, and 5 are the deviations or the distances from the mean. Are you clear the step number 3? Now, can you just take the average of this? Can you just give me the average of all these 5 data points? Minus 5 plus minus 3 plus 0 plus 3 plus 5 divided by 5. What is the average? Type in the chat box. What is the average? Just give me the average, calculate the average and type in the chat box quickly. Yes, so minus 5 plus minus 3 becomes minus 2. No, minus 8, sorry, minus 8 plus 0, so minus 8, then plus 3 becomes minus 5, minus 5 plus 5 becomes 0. So 0 divided by 5 becomes 0. Everybody got 0? Just give me a yes in the chat box. So the total of this becomes 0 because the minus and plus will clash with each other and you will get 0 as your answer, correct? Now, but does it mean we have 0 deviation? Zero deviation कब होगा guys? Zero deviation कब होगा? When we have all the data points at 15, 15, 15, 15, 15. That is zero deviation. Yes or no? No deviation at all. Every data point exactly on the same data. That is called zero deviation. But in this case, there is a deviation, but it is not getting reflected. So what statisticians do to overcome this challenge? They take the square of the deviation, because the squared value is always a positive value. See, minus 2 ka square becomes 4 and not minus 4. Understand this? Okay. So can we take the square values of this? Instead of minus 5, we take minus 5 square. Okay. So what is minus 5 square? It is 25. Then we take minus 3 square, which is 9. Then we take 0 square, which is 0. Then 3 square is 9 and 5 square is 25. So we square the deviation. And now we take the average. Can you just take the average of this? 25 plus 9 plus 0 plus 9 plus 25 divided by 5. Can you just take the average? That's a step number 5. Can you just take the average of this? It is called the average of the squared deviation. What is the average? Just give me the average quickly. So I'm not doing it. I'm just relying on your number. I'm not calculating it. Is it 9.6? Everybody getting the same value? Let me just wait for all the other people to come along. Everybody's getting the same value here. Shweta ji has already calculated 9.6. Same or different? Come on, guys, faster, faster. It's very simple. 25 plus 9 plus 0 plus 9 plus 25 divided by 5. 13.6. Okay, दो अलग अलग वैल्यूज आए हैं यहाँ पे. What is the real one? Okay, so Shweta ji has corrected it to 13.6. Okay, and everybody else is also. So the value is the average of the squared deviation comes to 13.6, and this is called variance. Variance is denoted by sigma square. Sigma square is called as variance. You can see here variance or sigma square is 13.6. Now, because we have taken the square, we have to take the square root of it. Can you just take a square root of this? Square root of 13.6. Just take a square root quickly. And that is our standard deviation sigma. It is 3.6, is it? 3.688. Is the same? Everybody getting the same thing? 3.688. 687. 3.68 we can say. So 3.68 is our standard deviation sigma. Now, how do we read this? This is very interesting. What is the meaning of 3.68? Imagine this is, let's say, weight of 5, let's say, junior KG students. Okay, or maybe, what is that? Pre-nursery. Somebody of 10 kg, somebody of 12 kg. Okay. So the, what I can say, the measurement, unit of measurement is kilogram. Standard deviation is 3.68. That also will be in the kilogram. Everybody make a note of this. Standard deviation will have the same unit of measurement like kilogram. If it is in centimeter, standard deviation will be in centimeter. If it is in meter, standard deviation will be in a meter. How do we read this? 3.68. That means on an average, listen to me very carefully. Standard deviation, how do you read this? On an average, each and every data point is 3.68 kilogram away from the mean. On an average, each and every data point is 3.68 kilogram. So standard deviation is nothing but simple layman's language में average distance from the mean. Average distance of all the data points from the mean is called standard deviation, which is the measurement of the dispersion. Are you clear with this? Just type yes in the chat box. Are you clear with this? Super clear? Everybody? Yes? Now look at this. Look at this example, guys. Okay. Here, n is equal to number of data points, which is 23. They have collected 20 data points. X bar is mean is 5 and standard deviation S. Now here, sample standard deviation is denoted by S and population standard deviation is denoted by sigma. Okay, so here they have denoted S, which is 1.75 units, whatever is there. Okay, so this looks like this. The next one, same sample size, X bar is 5 only, so the center remains same, mean remains same, but you can see a little less dispersion, so standard deviation has reduced. Can you see here? Lesser the dispersion, lesser the standard deviation. And look at the third sample, the same data points, same average, the center remains same, but look at the standard deviation 0.85. The spread is very, very low. The process is very much closely bounded. Okay, so standard deviation helps to understand the spread of the distribution. Are you clear with this? Just type yes in the chat box. With this example, is it clear? And this is what we want to achieve. We want to reduce. Are you clear? So what are we doing here? So let's say we have specification limits here, and whatever going outside of the specification limit is a defect, right? So we want to bring the process, very close so that the number of defects and rejection can reduce. And this is what is the summary of this entire DMAC framework. How many of you got it? Just type got it in the chat box. Got it, guys? Just give me yes in the chat box. Everybody? Super. Amazing. Okay, let me just share with you a file. Okay, just let me just quickly do a Minitab exercise here before we close the session. Just open this file. So when the standard deviation is low, okay, we can say the process is precise. Very good. But it may not be accurate. Understand this. Accurate where? When the process is hitting the target. When when the standard deviation is low, the process is precise. But when the standard deviation is low and the mean is hitting the target, then we can say the process is precise and accurate. Are you clear? Just give me yes. Okay, and we want both. We want precise as well as accurate. Okay. Super, super. Now, can you just open this file, guys? Let me also find that file and open that. Okay, just give me a second. Just give me a second. So let me go back to yeah. Yes. If you open the file, let me know. File open. Okay. If you are not in a position to open the file, if you're traveling, etc., it's okay. Just observe. I'll just quickly file this. Okay. Yeah. To open this file, there are conditions like you should have Minitab installed in your system. You should have laptop as well just to open the file. Okay. Shekharji, if you have just taken the admission recently, have you you've started accessing the Minitab? If yes, then this file will open. If no, I'll explain you how to do that. Okay. If you have iPad, there is a little different process we need to follow. Okay. So right now, what we will do is, okay, all the new members just observe what we are doing here. Okay. Just observe करो आज क्या कर रहा हूं, बाद में अभी प्रोसेस होने के बाद मैं आपको समझाता हूं कि क्या करना है. ठीक है. हाँ. Let's first clear this. First, all the new members just observe what we are doing. So this is a data point of chocolate weights. Okay. Chocolate weight है ये. So all the other people who are just practicing with me, what you need to do is just go to stat, basic statistics, graphical summary. Just observe here. Stat, basic statistics, graphical summary. The people who have the Minitab and they have opened it, just do it once, just to give you a glimpse of how you can do this statistical, stuff in the Minitab. Okay. Stat, basic statistics, graphical summary. इस पे click करो. In the variable, select the chocolate weight, double click on chocolate weight. That's it. Do nothing after that. Click on OK. And you will find this. Now observe here. First, whatever we have learned, this is called histogram. Okay, let me just make it in blue. This is called histogram. Correct? Which shows you the distribution. So this is the average. This is the spread of the distribution. And it looks like a normal distribution. Okay. This graph is called as box plot. Now, I have not covered box plot, but what I have covered is this. Okay. This shows this is the lowest value. LV is the lowest value. This is the highest value. HV is the highest value. This one, you can see here, this is called quartile 1. We have learned quartile 1 today. This value is called quartile 2 or median. And this value here is called quartile 3. And the graph which shows everything is called box plot. Okay, in some other day, we will cover this graphical representations as well, box plot. Are you clear, everybody? Histogram and box plot with quartile 1, quartile 2, quartile 3. Clear? Just give me a in chat box. Are you clear with this? Just give me yes. Super clear? Very good, very good. Now look at this. This portion is called as descriptive statistics, which we have learned. Okay. This portion is called inferential statistics, which we have not covered today. Okay. So in the descriptive statistics, have we covered mean, standard deviation, variance, number of data points. Yes, just give me yes in the chat box. Have we covered that? Everybody? Very good. Now, apart from that, have we covered the minimum? Minimum value is the lowest value of the data set. Then first quartile, second quartile or median, and the third quartile, the maximum value, which I have just shown in the box plot here. Just give me yes in the chat box. Yes? So this is how, with the help of Minitab, we can calculate all the descriptive inferential statistic instantaneously. That's the power. But we should understand what is the meaning of that. That's what I explain you with formulae, with the detailed analysis of it. Clear hai? Just give me yes. Everybody clear? Have you enjoyed the session? Yes, मजा आएगा इस प्रकार से सीखने के लिए इंटरैक्टिव एंड वी आर डूइंग along with together, we are learning, asking the questions, getting clarity, connecting with our own process. Yes, basic fundamentals. Sometimes what happens, we repeat this multiple times, but what happens, repetition because it clarifies your concepts. Yes. A squared is nothing but basically there is an Anderson-Darling normality test. Okay. So this is also inferential statistics, which shows whether the data is normally distributed. So there is a formula to collect A square. Okay. From the A square, we get a P value, which is the probability value. If this P value is greater than 0.05, if it is greater than, then this data is normally distributed, which is 0.256 indicates that this data is normally distributed data. It is a confirmation. It is a statistical test. Okay, हम लोग पढ़ेंगे इसको भी बाद में पढ़ेंगे. Clear? Super, super, super. Okay, now all the new members right now, what you can do is everybody save this number right now. 9930595248. Okay. All the new members, save this number. Okay. Meanwhile, anybody, any question you have, you can type the question in the chat box. If you want to ask the question, you can raise your hand. All the Minitab related questions, first of all, first save this number and give the name as mentor WhatsApp number. And this is only for the WhatsApp messaging and not for calling. Okay, this is a common number with all the other mentors as well. Okay, so because like you guys, we are also at the client's place, training, coaching, consulting, etc. So we may not be in a position to take the call immediately, but we can give the answer. Whenever we get time, we get the message in our WhatsApp and we answer. Okay, so you might find that we give answer very, very regularly on the WhatsApp. You can ask the question on email as well, but email answers will be given during the office hours only. WhatsApp answers will be given even in after office hours as well. आपको संडे में भी उसके आंसर मिलेंगे. ईमेल को आंसर सिर्फ ऑफिस आवर्स को ही मिलेंगे. Are you clear? So better to take the faster route, which is the WhatsApp. All right. Now, the people who don't have the Minitab, etc., on this WhatsApp number, first save this number and send a one-liner that I want to install Minitab. Kindly guide us. Okay. Even for the the Apple people, right? The iPad people, just send the message. I have iPad. Just give me the procedure. All right. And our team will immediately give you the answer. Clear, everybody? Just give me yes in the chat box. Super clear. So we'll connect every week like this on Monday as well as on Saturday, where your queries can get resolved. Plus hackathons also will keep on happening. Okay. You have a lot of recordings also to check first, but all the new members start with the first course number 1, which is green belt curriculum. Okay. So first you get the LMS, learning management system. I hope everybody has got the login ID password. Everybody, all the new members who have just registered yesterday or last week itself, you have all got the login ID password, right? any query related to login ID, password, mini tab, course access, anything, just send a message on the WhatsApp number and we'll be there to help you out. Clear? Super clear? Super. Amazing. Thank you very much for joining in. Keep learning, keep growing. This is Dinesh.